Welcome back to Three Inquisitive Kids. As you may remember from the last lesson, we learned all about how to remove brackets in linear equations. Now we're on to our third and final step of solving linear equations, which we will be covering removing denominators. Removing denominators in linear equations. Again, this is part 3 of our simplifying linear equations lesson. After that, we will move on to looking at the applications of linear equations in different types of word problems. Learning goals. Master the method of removing the denominator in solving linear equations. Master the solutions of linear equations with denominators and the steps of solving linear equations. Linear equations with denominators. Solve 3x plus 1 divided by 2 minus 2 is equal to 3x minus 2 over 10 is minus 2x divided by 5. So think, if the coefficients of the equation are made into whole coefficient equations, what number should be multiplied by both sides of the equation? And 2. What do we need to pay attention to when removing denominators? Let's think about this first problem. What number should be multiplied to both sides of the equation in order to get rid of the fractional parts? You can think of 3x plus 1 over 2 as 1/2 times 3x plus 1. Let me write that down. So you can think of it as 1/2 times 3x plus 1. But how can we get rid of this fraction? Well, what if we multiplied this by 2? What would that look like? If we multiplied this by 2, the 1/2 and 2 would cancel out, since 2 times 1/2 is equal to 1, and we will be left with 3x plus 1. So, well, actually, before that, let's look at another way we could do this. What if, okay, now let's think about it. What if we multiplied it not with 2, but with 4? Would 4 work? Well, it would still work, except we would have to still multiply 2 to 3x plus 1, which is equal to 6x plus 2. So again, we end up with a whole expression, just not as simple as the previous one if we were to multiply by 2. But still, we got rid of the denominator. So moving denominators is basically getting rid of the fractional part. And a lot of the times we do this so all the calculations are easier. I'm pretty sure that the majority of you guys deal with whole numbers better than fractions. So what number can we multiply to both sides of the equation? Remember, if we are going to multiply a number onto one side of the equation, according to the property 2 of linear equations, we must do the same to the other side in order for it to remain equivalent. But what number though? Let's look at the denominators, 2, 10, and 5. If we were to cancel out all 3 of these numbers, we would need a multiple that is both 2, 10, we would need a multiple that is of both 2, 10, and 5. What is a number that is a multiple of all 3 of these numbers? You might have come up with numbers like 100, 30, 60, and stuff like that, or 40. But what is the simplest we can get? That would be the LCM, or least common multiple, of 2, 10, and 5, which is 10. So if we multiplied 10 to both sides of the equation, we would remove the denominators. Okay, so our answer to this first question is the number that is multiplied should be 10, or the least common multiple of the denominators. Now let's think about number 2. What do we need to pay attention to when removing denominators? When removing denominators, what you need to pay attention to is especially if you have negative signs in front of terms, or if you have a term that has no denominator. So a lot of the times when people are removing denominators and multiplying a number on both sides of the equation, they often forget to multiply that number to the whole terms. For example, -2. You may multiply 10 to 3x plus 1 over 2, 3x minus 2 over 10, and 2x minus 2x over 5, but lots of people forget to multiply that to this -2 as well. So that's one thing you need to pay attention to. The other part you have to pay attention to is this negative symbol right here. So if you multiply 10, you have to think about it as -1 times 2x over 5 times 10, not just 2x over 5 times 10. So both of those are important things to be paying attention to when removing denominators. Here's the solution. First, you remove the denominator by multiplying both sides of the equation by the LCM of each denominator. So in this case, that would be 10. Now you simplify. So here, since the two, let's first just look at this first term. So since you multiply the 10, the 2 in the 10 and the denominator are canceled out, but there's still a 5 left. So you could write it as 5 times the sum of 3x plus 1. Same with all of the other terms, including fractions as well. And remember to multiply that 10 to this -2. After that, you remove the brackets, something we learned in the last video. Transpose terms, combine like terms. So really what you're doing is we have the same set of steps as the last two videos, except with the additional step in the beginning, which is removing the denominator. Combine like terms, isolate the variable, and then you have x is equal to 7/16. Let's do some practice based off of what we've just learned. Solve 1/5 times the sum of x and 15 is equal to 1/2 minus 1/3 of the difference of x and 7. Pause the video by yourself and use that series of steps we've just looked at to solve this problem. Alright, so the first step is to find the LCM, or least common multiple. If you don't know how to do that, which is something I expected you to know by now, but if you don't, or you would like some review, which is completely fine, you can go down into the description box where I will be putting the link to the least common multiple video that is also on our channel. Anyway, first, you see that there are 3 terms, and you multiply each of these by 30 since that is the LCM of 5, 2, and 3. First, you remove the denominators, and you get 6 times x plus 15 is equal to 15 minus 10 times x minus 7. And then you have your normal series of steps, removing brackets, transposing and combining like terms, isolating the variable, and you get x is equal to -5/16. When removing denominators from 2x minus 1 over 4 is equal to 1 minus 3 minus x over 8, the correct result should be blank. After multiplying both sides of 2x minus 1 over 3 is equal to x plus 2 over 4 minus 1 by 12, you get blank. Pause the video and choose the correct answers yourself, and then we'll come back and look at the correct answers. Okay, so this first one, what is the LCM of 4 and 8? So the LCM of 4 and 8 would be 8, and you would get D as your correct answer. Remember, don't forget to multiply 8 to this 1 as well, because just because it does not have a fraction, a fractional part, does not mean that you do not multiply the 8 to it. And for this next one, after multiplying both sides of this equation by 12, you get, well, the 3 and the 4 gets canceled out, except you still have 4 times 2x minus 1. 4 times 2x minus 1 is equal to 3 times x plus 12, 2 minus 12. And here's a reminder. When multiplying both sides of the equation by the LCM of each denominator, remember to multiply the term without a fraction. So in this case, the negative 1. At the same time, add parentheses to the numerator if it is a polynomial. So here, after the removal of brackets, we still had parentheses, so we didn't get confused, and we were clear, and we didn't rush a couple of steps into one line. So it's really important that you're keeping track of where you are and writing your solution out clearly. Solve. 1/7 of x plus 14 is equal to 1/4 of x plus 20. Well, first you remove the brackets, and you have 1/7 x plus 2 is equal to 1/4 x plus 5. Here we're removing the brackets first, since a fraction is being multiplied to a polynomial. After transposing and combining like terms, we have negative 3 over 28, x is equal to 3. Isolate the variable, and we get x is equal to negative 28. But from the second step to the third step, what we did was we multiplied both sides by 28 thirds, by negative 28 thirds, in order to get rid of that denominator. So we ended up with a whole solution, x is equal to negative 28. Do you have a different solution other than this? So here we removed the brackets first, but is there another solution? Here's method 2. First, you can remove the denominators. Find the LCM of 7 and 4, which is 28, and multiply 28 to both sides of the equation before using the distributive property to factor in 1/7 and 1/4. So instead, you have 4 times the sum of x plus 14 is equal to 7 times the sum of x and 20. Remove brackets, transpose, and combine like terms, and then you have x is equal to negative 28. So what is the difference between the two solutions? And which solution do you think is better? Let me just tell you the answers I have to each of these two questions. So the difference is that they kind of changed up the steps, right? So method 2 was thinking about these parentheses as a whole, and first dealing with the fractions other than the brackets. But in contrast, in the first method, what they did first was to factor in the fractions, and then they removed the denominators. In my opinion, I would use method 2 because I think it is simpler and quicker and cleaner, if you get what I mean, because you're first just getting rid of those denominators, and then you have whole numbers to deal with the rest of your way to solving there. So yeah, that's my opinion. What is your opinion? Feel free to comment down below. Converting fractions to integers is easier. That's my opinion. How do you remove the denominator in the equation in solution 2? Well, you multiplied both sides by 28. So here's the conclusion. The denominator can be removed by multiplying the left and right sides of the equation by the LCM, least common multiple of each denominator, which is based on the basic property. So it is based on the property 2 of the linear equation. So this is something we learned earlier on in this unit. And yeah, so it says if you multiply or divide the same, so if you multiply the same formula to both or expression to both sides of the equation, it will still remain an equation. And if you divide both sides by the same non-zero expression, it will still remain an equation. Solve. 2x minus 1 over 3 minus 10x plus 1 over 6 is equal to 2x plus 1 over 4 minus 1. Pause the video yourself and try to solve this equation. Well, first, we remove the denominators by multiplying both sides by the LCM of 3, 6, and 4, which is going to be 12. So then you end up with 4 times 2x minus 1 minus 2 times 10x plus 1 is equal to 3 times 2x plus 1 minus 12. And then you remove brackets, transpose terms, combine like terms, and then the solution would be x is equal to 1/6. Did you get the right answer or did you mess up somewhere? If you did mess up, I want you to go back and look for where you made that mistake and why you made that mistake, and then make a little note for yourself for next time where to pay attention to, and then this is the way that you're going to grow the fastest. So let's look at the solution for this equation right here. X plus 1 over 2 minus 1 is equal to 2 plus 2 minus x over 4. It's still that same series of steps, right? We first remove the denominators, and we have our brackets here. We remove these brackets, and we have 2x plus 2 minus 4 is equal to 8 plus 2 minus x. Transpose terms, combine like terms, and you have x is equal to 4. Now I want you to pause the video and solve this next equation. Alright, we have 3x plus x minus 1 over 2 is equal to 3 minus 2x minus 1 over 3. First, you remove the denominators, which is by multiplying both sides by 6, the LCM of 2 and 3. And then you have x, well, of course, all of these steps later, which I'm not going to go through precisely because that's what we've been working with the past 2 lessons. So you have x is equal to 23 over 25. Is the following solution correct? If not, where and why? So this is the problem. Solve 2x minus 1 over 3 minus x plus 2 over 2 is equal to 1. And this is the solution it wants you to look at. Is it correct? Well, let's analyze it. First it says remove the denominators, and then we have 4x minus 1 minus 3x plus 6 is equal to 1. And then it says transpose terms, combine like terms, isolate the variable, get x is equal to 4. So this solution is not correct because it does not tell us much about the solution, which is how you got it. It tells us the answer immediately, but not the steps that you got it in. For example, transposing terms, combining like terms, and isolating the variable are all separate steps. They are all separate steps that you slowly simplify this equation with. And you don't look at this equation and immediately get x is equal to 4. You have to write out each individual step, okay? And try not cramming everything into your head at once because that is a lot to process, and that just gives you a bigger chance for mistakes. Besides, if your teacher was grading this, say, they wouldn't see where you got something wrong, and they wouldn't be able to give you feedback. Also, when you're checking your own work, you won't be able to go back and see where you got it right and where you got it wrong. So this type of solution is not acceptable, and you should aim for clear one-by-one steps. Here's the summary. When removing denominators, you multiply both sides of the equation with the LCM of the denominators. And the basis for removing the denominators is the property 2 of the linear equation. And whole terms cannot be missed when removing the denominator, which means terms that do not include fractions will still need to be multiplied to. When removing denominators, write the two steps separately in your solution. Or not just two steps, maybe you'll have more. But what you're saying is, in your solution, you want it to be clear, and you want to be able to go back and go through your process of thinking. If functions 1/2 x plus k is equal to 1 and x minus 1 over 3 is equal to x minus k have the same solution, find the value of k. Well, first you can solve this first equation. So you have x is equal to 2 minus k. And then you solve the second equation. You have x is equal to 1/2 times 3k minus 1. We know that they have the same solution, so whenever you see the keyword same, or is, or equal to, you have to think about the equal sign. So since these two are the solutions to the two equations given in the problem, and we know that they have the same solution, 2 minus k has to be equal to 1/2 of 3k minus 1. Solved, k is equal to 1. Removing denominators in linear equations. Example 5. It takes 26 seconds for the train to pass through a 256-meter long tunnel. That is the front of the train to the entrance and the rear end of the train to leave the exit. That's the definition of passing through a tunnel. The train passes through a 96-meter long tunnel in 16 seconds. Find the length of the train, and also here the train speed does not change. I want you to think about this for a moment, but if you don't have a clear solution right away, it's okay. You can just come back and we'll walk through this together. So first, we need to set the variable. What is the length of the train? Well, we don't know that. That's why we're going to set it as the variable. So the first step is let the length of the train be x meters. And then the equation that can be given is 256 plus x divided by 26 is equal to 96 plus x divided by 16. So how did we get this equation? Well, this is the distance, and this right here is the time. So we know that velocity times time is equal to distance, or speed times time is equal to distance. And since the speed does not change, that's where we get the equivalent symbol. That's why we know it's an equation. So the distances minus the times, their corresponding times, they have equal speeds. And now 256 plus x, where did we get that from? Well, let's assume that this bar here is the length of the tunnel, okay? And for the front of the train to enter, so they're going this way, for the front of the train to enter here, and for the rear end of the train to exit the other way, so like here. And okay, let's say at the front of the train we place a flagpole. The flagpole at the beginning of this movement was right at the beginning at one end of the tunnel. But then when it ended, when it fully passed through the tunnel, it was the train's length away from that tunnel, and this is 256. So this total length would be x plus 256. Okay, we also have a Olympiad playlist where we talk about the different word problems they have in competitive math competitions like Math Olympiad, Math Count. So there is a set of problems that is called trains crossing bridges. So it's called trains crossing bridges, but it's the same as a train going through a tunnel. They're the same type of problem. So that link will also be in the description down below if you're interested and you would like to learn more about harder, more funner math problems like this. Okay, so anyways, that's how we got this equation. Now it's solving time. So here I don't have enough space, that's why I did not write out every single step. So solve x is equal to 160. But of course, if you were doing this problem on paper, you would have to write out each of your steps in solving it. The length of the train is 160 meters. Class summary. The steps to solving linear equations. This is the series of steps that we have been studying to and adding to, starting from part 1 of solving linear equations. The first step, and this is usually, any of these steps can sometimes be flipped around or switched around, to remove denominators, which is when you multiply the LCM of denominators to both sides of the equation. And then you remove the brackets. Parentheses first, and then the brackets, and then finally braces. So braces are these big things shaped like this, like a wave. And it's based on the distributive law of multiplication. Transposing terms, so you move variables to the left and the constant to the right, which is based on property 1 of the linear equation. Combine like terms, so add like terms and then add the constant terms. Remember, like terms are referring to the terms that share the same variable part. It's also based on the distributive law of multiplication. And then finally you isolate the variable. So it's based on the property 2 of the linear equation. When you turn the coefficient of the equation, say it's x, you want to turn the coefficient of x into 1. So isolating the variable, and you may have to multiply or divide something on both sides of the equation in order to do this. The 2 skills we learned today is to master the method of removing the denominator in solving linear equations, and mastering the solutions of linear equations with denominators and the steps of solving linear equations. Thank you so much for watching through Inquisitive Kids. In this past lesson, we have learned the 3 main ways to solving linear equations. Stay tuned for the next lesson when we'll be using these methods that we've learned to solve linear equations and applying them in actual real life problems. Thank you so much for watching through Inquisitive Kids, and I'll see you next time.